Hey guys, today we're going to talk about shoreline features and what happens at the shore and how it changes over time. So shores are shaped by the actions of wave, tides, and currents. Some are rockies and some others are sandy. Because of the way the ocean moves, it changes how the shoreline looks. So as wave height increases, it becomes breakers when approaching the shoreline. Remember, we talked about breakers in the previous lesson. And very large breakers are very powerful and can erode solid rock. And this destructive action is very evident at rocky headlands, which is the point where the land sticks out into the ocean as seen in this image. So let's talk about wave refraction. As waves slow down as they reach the shore, it causes the crests of the waves to bend, and this is called refraction. When it comes into contact with a headland, most of the energy is directed at the headland, and the headland is that area that sort of sticks out, and that's where all the energy is pushed. The rest of the energy is spread out, all right? As a result, headlands undergo significant erosion and then are eventually worn back and the shoreline straightens. So straight shorelines are older than shorelines that have cliffs and headlands. So because of this erosion, we see some really awesome rock formations. So our first image here shows a sea stack, which are isolated rock tower. We also get sea arches as seen in this second, the center image. And then we also see sea caves, which are tube-like passages into the headlands. So what do beaches look like? Some of you have probably been to the beach. Beaches are sloping bands of sand, pebbles, gravel, and mud at the edge of the sea, and they're composed of sediments deposited by waves along the shoreline. All right, the size of the sediment depends on wave strength and the source. So large waves or rocky coasts are a result of coarse sediments, and that's such as pebbles and cobbles. Black sand comes from volcanic rocks, and they're generally pretty coarse. White and pink sand comes from coral, seashells, quartz, and feldspar, and that is a very fine grade makeup. So estuaries. Are areas at the bottom, at the end of a freshwater river where it lets out into the ocean. And the water there is called brackish because it is a mixture of fresh and salt water. So definitely think back to our density and salinity lab and think about how water mixed when you combine salt water with fresh water. These estuaries are nurseries to the young of many different species, so they're very essential to be protected to help maintain endangered species and even non-endangered species that are very essential to ecology. All right, longshore bars. So some of you may have experienced this, but sometimes when you walk into the ocean, it gets deeper and then suddenly it gets shallow again. And this is called a longshore bar or a sandbar. What happens is the waves break on the longshore bar, creating a surf zone. And the deeper water close to the shore is called the longshore trough. And this image shows you the lagoon and the sandbar. Longshore currents. As water from breakers spills over the longshore bar, a current flows parallel to the shore, and this is called the Longshore Current. Movement of sediments. Longshore currents move large amounts of sediment, and they move sediments in the direction of the longshore current. All right, barrier islands. This is particularly relevant to North Carolina. Barrier islands are long ridges of sand or other sediments that are deposited by longshore currents, and they're separated from the mainland. Examples are the Gulf Coast or the East Coast of the United States. Barrier islands are generally unstable and temporary, and major storms can sweep entire sections away of the islands, and the beaches slowly erode away over time. These are some images of how barrier islands are set up. On the back side of the barrier island is called the back barrier. You have in the back barrier, you have two areas called the toe, and then you have the barrier island and the ocean side shore face. You also have the swash zone. All right. In these areas, you can see the formation of tidal flats, salt marshes, tidal bars, and flood deltas. And then you see inlets, tidal bars, inlets, and sound shoals, and also an ebb delta can also form. So let's look at some of the depositional features of seashores, okay? Most seashores are in a constant stage of change. So, and longshore currents build various landforms. You can have the spit, which is a narrow bank of sand that projects into the water from a bend in the coastline. You can have a bay mouth bar when a spit crosses a bay. You can have a lagoon. These are shallow protected bodies of water behind a bay mouth, bars, or barrier islands. And you can also have a tombolo, which is a ridge of sand that connects an island to the mainland. And so this lovely image here shows you examples of lagoon, marshes, estuaries, barrier islands, spits, bay mouth bar, and tombolos. All right, rip currents. If you frequent the beach, you've probably heard of rip currents. And these are produced by simple wave action. Rip currents flow out to the sea through gaps in the longshore bar, and they can move really fast. They're very dangerous. A quick tip, if you do get caught into a rip current, do not try to swim against it. Try swimming parallel to the shore, and that will eventually help you come out of the rip current and be able to swim back in, as these images show you some rip currents and what that looks like from the shore and when you're above it. So let's talk about protective structures. So seawalls, groins, jetties, and breakwaters are built to prevent beach erosion and destruction of oceanfront property. They can have negative effects because they block the natural shoreline processes. So seawalls actually worsen beach erosion. Groins deprive beaches down the coast of sand. Jetties trap sand upshore, but they prevent sand from reaching downshore, and they often require dredging. And then breakwaters block the current, so sediment can't move, and that also requires dredging. All right, so changes in the sea level. During the last ice age, the sea level was 130 meters lower than it is today. And since then, we've had melting of glaciers, and that has slowly raised the sea level to its present level. In the last 100 years, the sea level has risen between 10 and 15 centimeters, depending on where you're at. And scientists estimate it will keep rising about 1.5 to almost 4 millimeters a year, and approximately 30 centimeters in the next 70 years. Many people agree that this is due to global warming because Earth's temperature is rising, causing the seawater to warm up, and this causes the seawater then to expand. And in addition, glaciers melt, also increasing the sea level. So what are some of the effects if the sea level changes? If the Earth's remaining polar ice sheets melt completely, the sea level would rise about 70 meters. This would flood some countries, states, and cities. However, this will not happen soon, but if the temperature continues to rise, we could cause a rise of up to 6 meters. And what sort of changes happen? So fjords, which you find in places like Sweden and Norway, these are deep coastal valleys that were scooped out by glaciers during the last ice age, and then were flooded when those glaciers melted. And this is a lovely image of a fjord. All right, so let's talk about tectonic forces. So we looked in our previous unit at plate tectonics and earthquakes and all those things. So how does this change the seashore? So tectonic uplifting and sinking can cause changes in the sea level. If a coastline sinks, the sea level rises. If it rises, the sea level sinks. So the west coast of the United States is slowly rising, and that makes it called thus, the west coast is called an emergent coast because it was formerly underwater. And this makes marine terraces become elevated. So those things that were once underwater are now visible. So what is the effect of these tectonic forces? So if there is an earthquake that occurs in the ocean, or there's some sort of change in the tectonics, you can get a tsunami, which is a catastrophic ocean wave. I'm sure many of you have heard of it. And this is caused by submarine movements, earthquakes, volcanic eruptions, landslides beneath the ocean, or an asteroid striking the Earth in the middle of the ocean. All right. They're also called seismic sea waves, or also called tidal waves. Here is an image related to a tsunami that occurred in the Indian Ocean in 2004. It affected Sri Lanka, India, Sumatra, and those areas, and it caused significant changes in ocean levels. Another major tsunami that occurred was in just off of the coast of Japan, and it caused some very significant damage, especially with nuclear power plants. It was a magnitude 9, and it occurred in 2011.